whenever you are telling the displacement 5 kilometer, okay, but it is a vector quantity, okay, or distance, it is a scalar quantity, whereas displacement is, it is a vector quantity. You know, the vector quantity means it has both direction and magnitude. So whenever the magnitude of displacement is 5 kilometer here, but if you will give the complete information of the displacement, so I can say it is from A to B. Which direction is there? From here you can see it is towards east. So I can write 5 kilometer towards east. So this will be the complete information for the displacement. So it is a vector quantity because magnitude and direction you have to mention. But when it is given that what is the distance covered, it will be 9 kilometer. Only magnitude is there, no direction is mentioned, or no need to give any direction. It has no direction actually. That is why distance is a scalar quantity and displacement is a vector quantity. And another difference, if you will compare the SI unit, the SI unit, standard unit of distance is meter. You know the length we normally use meter, kilometer is the bigger unit, meter is the standard unit of distance, and whenever you are expressing displacement, also meter will be the standard unit of displacement. So the SI unit of distance and displacement both is meter. Okay. So thing is that in that if we take another example, that the object is moving from A to B, okay, then B to C, C to D, something it is 5 kilometer, then it is say 2 kilometer, it is also 2 kilometer, then again it came to here. So in this case, you see, if it is given the distance, then you will write 2 plus 5 plus 2 plus 5 equal to 20 kilometer, 14 kilometer. Okay, but if here displacement is asked, then what will happen? You see, this is the initial point, and after covering A to B, B to C, C to D, again it reaches to A. This is also final point. So point A is initial as well as point A is final. So displacement is the distance between initial and final point. Then what will be? Displacement will be here 0. So when an object starts from a point and again come back to the same point, at that time displacement becomes 0. So distance cannot be 0, because if object is moving, then it should have traveled some distance. Means distance cannot be 0 for a moving object, but displacement for a moving object may be 0. And when the displacement becomes 0, when the object starts from a point and again return back to the same point after covering different path, then it is, the displacement becomes 0. So another thing is that the distance and displacement, when you compare, always distance and displacement, who will be bigger one? If you compare the magnitude of distance and magnitude of displacement, here you can see the distance is 9 km, displacement is 5 km. So normally the distance is more than displacement, but distance and displacement may be same. Sometimes distance and displacement becomes equal, and when will be there? They will be equal if the object moves from A to B and it is a straight path. So it is 10 km. So in this case, the distance is 10 km, the path actually traveled by the object, and here displacement is also 10 km. Why? Because the shortest distance, the straight path is also, the distance is 10 km. So I can say when distance and displacement becomes equal, I can say that when the distance between or an object moves in a straight path, then the distance traveled and displacement becomes equal. Okay, so distance and displacement may be equal. Distance may be more, displacement may be less. Okay, and here displacement becomes 0 and distance will not be 0. Distance cannot be 0 for a moving object, but there will be no such case where displacement becomes more and distance becomes less. It is not possible. Again I am telling, listen carefully. If you compare the magnitude of distance and displacement may be equal, like this case. Distance may be more than displacement, like this case. Displacement becomes 0 in this case, but no such cases will be there where displacement is more than distance, because the straight path you can move. You cannot make more shorter distance than straight path. So displacement cannot be more than distance traveled. Okay, so this is all about the differences between distance and displacement. Then we'll read about another thing, that is distance time graph. You know that when we draw any graph, it has two axes. Okay, this is origin, this is y-axis, this is x-axis we are telling, but in this case the x-axis will become time axis, and here the y-axis will be distance. And the distance time graph, when it becomes straight, it means that actually you will find the point, means if the distance covered and time taken becomes equally changes, means an object covered equal distances in equal time interval, then the graph will be straight, and this graph is for uniform motion. It means an object is in uniform motion. A object is said to be in uniform motion if it covers equal distances in equal interval of time. So I can define here that an object is said to be in uniform motion if it covers equal distances in equal intervals of time. So if we'll do the graph, that for example here it is say 5 meter in 1 second, then 10 meter in 2 seconds, say 15 meter in 3 seconds, 20 meter in 4 seconds, and if we find out the graph here, okay, it will be, you will get such point, and if you join this, then it will become straight. Okay, so always students remember that for uniform motion the distance time graph will be always straight line. So sometimes it is asked that draw the distance time graph for a uniform motion. So what you have to do, you have to draw like this. You have to not mention any value here. Simply you have to write time in the x-axis, distance in the y-axis, and you have to draw a straight line. So this is the graph of an object which is in uniform motion. And just opposite, if you compare the non-uniform motion, that is non-uniform motion, so just opposite of uniform motion, if the distance covered by the object is not same with time, means if the object covers unequal distances in equal intervals of time, then it is said to be in non-uniform motion. It is in motion, no doubt, but the motion is non-uniform. And what will be its graph here? You see, for example, in first second it moving 5 meter, and next seconds it is moving 7 meter, like that. It is again say 12 meter. So what will happen? So if we will do the graph, then first second it is 5, in second it becomes 7, so 7 will be like this, okay, and third it is say 12, it will be like this. So if we will do the graph, it will be the bent one, like this. So if the graph is not straight, it is a curved line, then we can say it is non-uniform motion. So if, again I am telling, if the question asked draw a distance time graph of a non-uniform motion, then simply again like that, what you have to do, you have to write time in the y-axis, distance in the y-axis. No need to mention all the data here. If it is data is given, it's okay, but if simply distance time graph you have to draw for non-uniform motion, then you will do any curved line here, like this, or maybe like this. Any curved line represents non-uniform motion, whereas if the distance time graph is straight, then it is uniform motion. This is for uniform motion, this is for non-uniform motion. Okay students, I think it is clear about the uniform non-uniform motion and what will be the graph, distance time graph of uniform motion and non-uniform motion. I think you have understand all the concept about this uniform and non-uniform, physical vector quantity and scalar quantity, and distance and displacement. I think you will enjoy by watching this video. Thank you very much.